Today we will be doing the Imine Formation. Alright. Usually for an amine, you have a carbonyl compound. And then you also have your amine as well. This reaction is typically acid catalyzed. I will explain that. I'll explain what that means later. Alright, acid catalyzed basically is when you add a proton at the oxygen atom to make the carbonyl a better electrophilic compound. I will go ahead and show you what I am talking about. It would be something like this. There's your proton. It now adds into the oxygen. And now you have your protonated carbonyl. The reason why this is a good electrophile, the reason why this makes a carbonyl a good electrophile is because if you bounce up the double bond to create its resonance form, you would see that the carbon has a positive charge right here, which makes this a really good electrophile for attack by a nucleophile. But we're going to go ahead and use the first resonance. Alright, so what happens now is you have your attack by your amine, which is always a good nucleophile. So once that happens, you create something like this. There's up the pens here. And there is your intermediate stage. The next step would be water functioning as a base and would rip this proton off. Because actually, once the amine attacks, there's a positive charge right here on the nitrogen. So once water rips off the proton, you now replace that lone pair on the nitrogen. So your product will look something like this. Alright. The next step now is we've got to make this hydroxyl group, the proton and the oxygen, into a leaving group. So I'll go ahead and redraw this on this side. Sorry, I'm not drawing in the same color. Apologize. So we have the same compound that we had on the far right. And now we've got to make this into a good leaving group. So we add something like, we can use water. Water can add a proton. So once that happens, we have this. And this is an excellent leaving group, and leaving groups typically leave. And once that happens, we've also still got to maintain the octet on the carbon, so this lone pair is going to shift up as well. So here we go. Our product will look something like this. But once again, you have a positive charge on the nitrogen, which basically leads us to our last step of the imine formation. I will redraw this again on this side. So the next step is a proton, or sorry, a base, like H2O in this situation, would once again attack, or sorry, deprotonate to reform the double bond on the nitrogen. So here we go. And that's basically your amine, but I'm going to go ahead and redraw this to look better. And that would be your amine. So that is your amine. So you used a carbonyl and an amine to form your amine. Thank you for listening to my tutorial. Hope to see you again next time.